The Big Bang. That moment when the universe was born. The point where everything began. But one question remains unanswered. What came before that? If even time and space began with the Big Bang, is it even possible to speak of a time before that? The Big Bang theory is essentially based on two fundamental ideas: the universality of physical laws and the cosmological principle. As mentioned earlier, the cosmological principle assumes that the universe is homogeneous and isotropic at macroscales. The cosmic microwave background is an electromagnetic wave discovered in 1964 that fills the entire universe. It was precisely measured outside the atmosphere by the COBE satellite at a frequency of 160.2 GHz and a wavelength of 1.9 millimeters, corresponding to the thermal radiation of a blackbody at a temperature of 2.725 Kelvin. The dark lines of an absorption spectrum are shifted toward the right, or red, end of the spectrum. This shift is a result of the expanding universe. As light reaches Hubble's mirrors from great distances, it is stretched, or cosmologically redshifted, toward longer red wavelengths as the universe expands. Time itself begins here. Different cosmological models that accept cosmic inflation, the belief that the Big Bang is based on the first or initial moment of the universe's history, is a misconception. The Big Bang merely indicates that the universe went through a dense and hot period. This is not just a philosophical problem, it is a physical problem. The entire universe is the result of a vacuum fluctuation, and this is due to a state we call quantum nothingness. Scientists like Stephen Hawking suggest that a major crunch, known as a Big Crunch, could also occur. The universe is born with a Big Bang, then, upon reaching its maximum size, runs out of energy and collapses inward. For example, this theory also includes the following: the universe has been born and collapsed billions of times. It will continue to collapse and re-emerge into a Big Bang. According to this theory, our universe is just one of these bubbles. And even more incredible, the process of cooling from the unimaginable temperatures at which inflation occurs can alter the fundamental laws of the universe. Different bubble universes may have different laws of physics. There are two situations where time stops for us. One is inside singularities. Another situation where time will end, or rather, where the value of time will cease to matter, is the Big Crunch, which will occur as a result of the Big Crunch theory. So why does time cease to matter? Why does time cease at the singularity? The short answer is that there is no reference system we can define at singularities. In this case, the values x, y, and z cease to matter, and consequently, the value of time ceases to matter. Is there an end to humanity or the end of the universe? Absolutely yes. The universe and humanity will each have an end. While there are many endings for the end of humanity, we have fewer theories for the universe. Nothingness isn't a concept that has a real-world equivalent. When you look at the issue in terms of color, if you consider the color, black, as an example of nothingness, you're mistaken. This is because it's a color you only see in the physical environment when there's no light or when you close your eyes, and because of these conditions, black is associated with the nothingness of something. However, if we were to observe the color red in the absence of light, if we were to see red when we closed our eyes, which would be possible given our evolutionary path, then the color of nothingness would be red. Is nothingness truly possible? Perhaps there's no definitive answer to this question, but the important thing is to keep asking. Because understanding the universe is, in fact, understanding ourselves. What do you think existed before the Big Bang? Subscribe to my channel and share your thoughts on this topic in the comments.